Morning. So today we're going to start the new chapter, that is the estimation of the organic compound. That is the first part of the organic chemistry. Most of the time, what happens, the teacher starts with the nomenclature and all this organic chemistry. But the estimation of organic compound mostly asked in the questions in the board also, and also in a NEET examination every year one question asks, and a JEE main and a JEE advanced question also asked from the estimation of the organic compound. So the estimation means what? Estimation means you want to estimate the organic compound. So we know basically the organic compound consists of compounds of the carbon and the hydrogen, that is the major constituent. Apart from that, there is the other heteroatoms are there, like the halogens are there, sulfur there, nitrogen there, phosphorus is there. These are the minor constituents, and most of the time these elements are also present. So the major constituent is the carbon and hydrogen. So the estimation is two types of estimations are there. So first one type of estimation is the qualitative estimation. Qualitative estimation means we have to know the quality or the nature of elements present in the organic compound. Again, I am repeating. There are two types of estimations are there. One is the qualitative, other one is the quantitative estimations. So in the qualitative estimation, we have to know the nature of the elements present in the organic compounds. But in quantitative estimations, the quantity, the amount of the element or the percentage of element present in the organic compound. So we'll start it. So today's topic is the estimation of compound. Estimation of organic compound. There are two types of, as I told, that is two types of estimations. What are the elements present? Major constituent is carbon, hydrogen, and oxygen, nitrogen, sulfur, phosphorus, halogen. These are heteroatom and these are homoatoms. Okay, so the estimation of organic compound, so that is clearly analyzed here. So one is the qualitative, one is the qualitative estimation. In qualitative estimation, we can know the nature of elements, the nature of elements, what type of elements present in it. And in a quantitative estimation, so the another one is the quantitative estimation. In quantitative estimation, we can know the quantify the quantity or the percentage of element present in the organic compound. So we are going to discuss the two parts. So one is the qualitative estimation and the quantitative estimations. The qualitative estimation and the quantitative estimation to quantify the elements, and it is the nature of the elements to know that. Okay, you can note down. So So first of all, we will start with the qualitative estimation. So qualitative estimation, let me write down here. Qualitative estimation. That means we can know the nature of elements present in the organic compound. So in qualitative estimation, the first we will see the detection of carbon and hydrogen. The detection of the carbon and hydrogen. So this detection is not needed because no such compound exists, organic compound exists where the carbon hydrogen is not there. So, but still then for the detection, for the confirmation, we can do the test. Because without carbon and hydrogen, we cannot imagine an organic compound. So this detection is not necessarily, because it is organic compound means that is definitely the carbon and hydrogen will be there. Detection of carbon and hydrogen, the detection of carbon and hydrogen. So that is the cupric oxide used as the oxidizing agent. So the oxidizing agent that is used as the cupric oxide. So the carbon, when heated with the cupric oxide, so it is converted to copper plus carbon dioxide. So that means it will be this oxygen is taken by the carbon. So it will produce the carbon dioxide. So with this gas is a carbon dioxide or what gas it is. So that we can know with this carbon dioxide gas, the detection, the test of carbon dioxide, we know it can pass through the lime water. When it is passed through the lime water, it turns it is milky. The formation of calcium carbonate precipitate plus water. So that is the turning of the lime water to milky. The taste of the carbon dioxide formation will be indicated by the formation of the this white precipitate or the milkiness will appear. The formation of the milkiness that indicate that it is made up of the carbon dioxide. Carbon is present in the organic compound. So similarly, the estimation of the hydrogen. So for the estimation of the hydrogen, so what we have to do for the estimation of the hydrogen? If the hydrogen is present when it is heated with the sulfuric oxide, it is converted to copper plus 2H2. So we have to 2 hydrogen, so that is the bioequation. So whether this is water or something else is formed, so that is the test of water is there. So this water, when it is heated with the white color copper sulfate, so that converted to copper sulfate 5H2. That is called that is blue color. So so it is formation of the conversion of white to blue. Conversion of white to blue is the test of the conversion of white to blue is the test of that is the water. Water that is detected. Normally, water is detected by the presence of the white color copper sulfate converted to copper sulfate 5H2. That is the detection of hydrogen. So the presence of water indicates that the hydrogen is present in the compound. Presence of carbon dioxide, formation of carbon dioxide indicates the presence of carbon. So that is it is called the detection of the carbon and the hydrogen. So we know that is the copper sulfate 5H2O, that is the triclinic structure. It in the solid state will come across it. It is the copper sulfate pentahydrate. It is the only compound where the all types of bondings are present in this compound. So this is the blue vector. It is called as the blue vector. Okay. So this is all about the detection of the carbon and a hydrogen. Next, we will go for the detection of other elements. For the detection of the other element, so because these elements are present in the covalent bond form, so the halogen, sulfur, nitrogen, phosphorus, these are all present in the covalent bonding state. So the covalent bonding state, when it will on any test for the detection, if will undergo the test, so the covalent bond will react very slowly. That the detection is not possible. So our first aim is to convert the covalent bond to the ionic bond. So to make it ionic, so compound should be the ionic form, it should be converted. That is why these elements, the organic compound is fused with the sodium. The sodium is the reactive metal, it is kept in the kerosene. So this sodium, when it is fused with the sodium, so this is called the Lassine test or the extract which comes out, that is called the Lassine extract. So what will happen? The Lassine test, that is called the Lassine Lassine test. That is Lassine test. In the Lassine test, what will happen? So the organic compound, this is the organic compound, fused with the sodium, it is converted to Lassine extract. That we can write for that is the Le. The Le is the Lassine extract. So what will happen? This sodium react with the carbon and nitrogen to sodium cyanide. So this is ionic compound. The sodium, if the sulfur is present, it is converted to sodium sulfide. This sodium, if the halogen is present, it is converted to sodium halide. So these are the lacine extract. But if the both the sulfur and the nitrogen is present, so it will convert it to sodium thiocyanide. If the both present, if both nitrogen and sulfur present, so it will convert it to sodium thiocyanate. So this is the happen the organic compound. Due to sodium, sodium is a very reactive metal, and it is converted to extract comes, that is called the lacine extract. So in this way, the carbon, nitrogen, sulfur, and halogen can be detected. You can ask me, so why you are not talking about the phosphorus? But actually, the phosphorus is not detected by the lacine extract. That many times this question is asked in entrance. So, what is the element is not detected by the sulfur? So this extract is called the lacine extract. So with the lacine extract, we can detect the different elements. So the first we will go for the detection of the different halogens. First we'll start with halogen. That will be easier for your understanding. Then we will go with the so the lacine extract what we have done. So the first will be the number one, that is the detection of halogen by the lacine extract. So you see the lacine extract, we do not know the what kind of halogen it is there. It is present in there, present there. So to the lacine extract, that is the which is present in the NaX form. So if it is treated with the silver nitrate, so then there is a possibility that depending upon the nature of X, there is a three types of possibilities are there. So this nitrate will be replaced by the sodium. So this is the NaX plus AgNO3. So what you will expect? So you will expect that is the AgX, the precipitate will form. So if the X is equal to Cl, then the AgCl will form. Yes or not? If the X, it will convert it to AgX plus NaNO3. This is the reaction takes place here. So from the if the X is Cl, then it will be AgCl will form. If X is equal to Br, then AgBr will form. If X is equal to iodine, the AgI will form. So you see the color of these precipitates are different. The AgCl is the white precipitate. The presence of the formation of the white precipitate that indicate that the halogen, the chlorine is present in the organic compound. If it is gives the dirty yellow precipitate or faint yellow precipitate, then it indicates the bromine is present in the organic compound. It gives the deep yellow precipitate, then it is called the iodine is present. But problem is, so this dirty yellow and yellow both are looking like a yellow color. Both are looking like yellow color. So it is if it is the ammonium hydroxide is added to that, ammonium hydroxide is added. So what will happen? So with the ammonium hydroxide, so this will be soluble because it will form the complex. But here it is also soluble, but here it is insoluble. So because the both are yellow color, because the both are yellow color, so because of the both are yellow color, so we can know. So this is the whether it is soluble or insoluble. Both are yellow color, but if it is this solubility, if both are yellow color, but if it is soluble, then it is as if bromine will be there. If it is insoluble, then the uh, iodine is present. Okay. So this way the detection of the halogen is possible. But you can ask me, I am not talking about the fluorine. The fluorine cannot be detected by this method because it is highly reactive. So the fluorine cannot be detected by this method. So then we will go for the detection of the nitrogen. possible. That nitrogen detection is possible. So the the lacine extract, that is the sodium plus carbon plus nitrogen, it is converted to sodium cyanide that we have written. So when the lacine extract is treated with the ferrous extract, is treated. Okay, I am let me write here. So this is the ferrous sulfate. So it will converted to Na FeCN whole 6. So that will be ferrocyanide. So it will be plus 2, it will be minus 6, delta. So this is a sodium hexacyanoferrate. So that will be 6 and converted to sodium sulfate also. So that is the sodium hexacyano or sodium ferrocyanide we can write. Sodium ferrocyanide. So this is the compound. This sodium ferrocyanide, some of the sodium ferrocyanide, some of the ferrous form, it is converted to ferric form also. So when it is not needed to add the ferric sulfate, but if you add also, it gives, but without adding also, it will also give the product. Because some of the Fe plus 2 stage, it is converted to plus 3 stage. So it will converted to Fe ferric ferrocyanide. It is converted to ferric ferrocyanide. If you put, it will be FeCN whole 6 and it will be 3. So this is the plus 3 stage. This is the iron. This iron in the plus 3 stage. This iron in the plus 2 stage. So this is called as the ferric ferrocyanide. So many times the question asks what is the oxidation state of iron. So one is the plus 2 and another is the plus 3 stage. So that is the ferric ferrocyanide, that is called the Prussian blue precipitate. That is called the Prussian blue precipitate. Many times the question asks in also. So what is the oxidation state of the iron in Prussian blue precipitate? In a Prussian blue precipitate, that is one is the plus 3, another is the plus 2. The two iron, two oxidation state is present. That is the Prussian blue precipitate. But here I have to tell you the one thing. So there are some compounds, that is some functional group of the carbon that cannot be detected. So one is the azophone. If the nitrogen present in the azophone, it cannot be detected because the breaking of this bond will be not possible easily. So in the azophone. So if it is present in the hydrogen form, that also not detected. If it is present in the amide form also, that hydrogen detection of the nitrogen is possible, but this it will be react with the soda lime. If it is heated with the soda lime means sodium hydroxide and calcium oxide, it will be converted to carboxylic acid and plus ammonia. So that is another method, but hydrogen extract these functions not detected. That is for your understanding, you have to remember. So the azo group, hydrogen and acid amide, it is not detected by this Prussian group precipitate form. That is for your understanding. So now I hope you understand it clearly. So that is the ferric ferrocyanide, the Prussian blue precipitate. The formation of the blue precipitate indicate the nitrogen present in the organic compound. The formation of the Prussian blue precipitate indicate the presence of the nitrogen present in the organic compound. So sometimes what happens, both the nitrogen and the sulfur also present in the organic compound. As I told, the sodium plus sulfur plus carbon plus nitrogen converted to sodium thiocyanide. So the sodium thiocyanide is the ferric chloride is added. It is converted to FeCN3. That is the ferric thiocyanide. So that converted to ferric thiocyanide. The ferric thiocyanide, that is the blood red color. The blood red color precipitation to the lysine extract. This is the lysine extract. To the lysine extract, if the ferric chloride is added, if this give the blood red color, so that indicates both the nitrogen and sulfur present in the organic compound. Both the nitrogen and sulfur present in the organic compound. That is indicated. That is the presence of the lysine extract. So one more test is there for the halogen detection, that is called the Belistens test. In Belistens test, the copper foil, the organic compound is heated with the copper foil. So the on the flame coloration, if the green color flames are formed, so that presence of the indicate the halogen. That is called the Belistens test. Belistens test, that is used for the detection of the halogen. So now we have completed the carbon, hydrogen, we have completed nitrogen, we have completed both the nitrogen and sulfur. Now we see the presence of the presence of sulfur by detection of sulfur. Detection of sulfur. So detection of the sulfur, the lysine extract, as I told, that is sodium plus sulfur, it remains as Na2S. So this is the lysine extract. So this sodium sulfide, so when it is heated with the lead acetate, when it is heated with lead acetate, it is converted to PbS plus sodium acetate. So the formation of the this black color precipitate of the lead sulfide that indicate that is the lead is the present, the sulfur is the present in the organic compound. So that is one method. So another is the another method. It is the method number one. So another is the sodium nitroprusside method. This Na2S when heated with the sodium nitroprusside. Sodium nitroprusside is this one is the sodium nitroprusside. This compound is called as the sodium nitroprusside. This compound is called as the sodium nitroprusside. In sodium nitroprusside, so in sodium nitroprusside, so what happens when it reacts with this? It is converted to no changes is there. It is converted to FeSCN converted. FeSCN whole 5 NO. So this is sodium sorry NOS conversion. So this is called this color is the violet color. The formation of the violet color in the sodium nitroxide test, it is give the violet color uh, that indicate the sulfur is present in the organic compound. The presence of sulfur, that is the two methods are there. So one is the sodium nitroprusside method where it gives the violet color. So another is the sodium, that is the lead acetate method, that gives the black acetate. So the remaining one is the detection of the phosphorus. So as I told, the phosphorus detection is not possible by the lysine extract method. So that is it has the own method. The sulfur, the detection of the sulfur is done by its own method. So sulfur, the detection of phosphorus. So the organic compound where phosphorus is present, organic compound where the phosphorus is present, it is oxidized by the sodium peroxide. Sodium peroxide is a strong oxidizing agent. So the phosphorus present is converted to phosphate form. Here the phosphorus is converted to phosphate form, sodium phosphate. So this phosphate, it is boiled with ammonium molybdate. It is boiled with ammonium molybdate, which is converted to yellow ammonium molybdate. That is the test of phosphorus. So this is the sodium phosphate. Sodium phosphate. This sodium phosphate heated with the nitric acid. First, it will be heated with the nitric acid. So it will converted to sodium nitrate plus phosphoric acid. Sodium nitrate plus phosphoric acid. And the phosphoric acid, that is the H3PO4, heated with the ammonium molybdate. Heated with the ammonium molybdate. You know that is the molybdate ion, AMO4. It is the molybdenum oxides, molybdate ion. So the converted to, it is heated with the ammonium molybdate. It is converted to yellow ammonium, phosphoammonium molybdate. It is converted to plus nitric acid also, in presence of plus nitric acid. In presence of, not, I am not doing the balancing. So that will be converted to ammonium phosphomolybdate. That is the NH fourth whole 3 PO fourth dot 12 MO3. That is, sorry, MO4, no, MO3. That is the ammonium phosphomolybdate. That is the ammonium phosphomolybdate. So this is the yellow color. The presence of this phosphoammonium molybdate, that is the test of, that is the yellow ammonium molybdate, that is the test of uh, phosphorus. So here the ammonium nitrate is also formed. The ammonium nitrate plus water is also formed. So the formation of this yellow color precipitate indicate the presence of phosphorus is there in the organic compound. That is, the presence of phosphorus in the organic compound can be detected by this way. So we can balance it also. That will be 12, that will be 21, that will be 12 and 21. You can just telling you the balance. That is the 21 and it will be 12. And this is 1. So this way it can be balanced, and this is all about the qualitative analysis. And then next video we will see the quantitative analysis. You can subscribe my video, that is the Barik Sir Chemistry. So gradually one by one video I am adding in the YouTube. So you can subscribe to the Barik Sir Chemistry, and I will noting my number also. If you have any doubt, or if you can join for the complete course also, you can join with this number, or my the mail ID is kcbarik@gmail.com. This is the mail ID and this is my phone number. And if you want, you can join with my classes also, online classes. So this is my uh, this is the estimation of the organic compound. We have discussed about the qualitative estimation. In the next video, that I will cover, that is the quantitative estimations. So the, in qualitative estimation, the resistance test that is used for the halogen detection, fluoride is not detected by the Rasayan test, and fluoride is also not detected, phosphorus is not detected by Rasayan test, and nitrogen, sulfur both can be detected by the blood red formation, blood red precipitation, uh, by the formation of the ferrocyanide, ferrothiocyanide. So this is the, this is all about the estimation of the organic compound qualitative, part 1 video, and the part 2 that I will explain you the quantitative estimation. So you can subscribe my channel.